The recent emergence of an unusual warning from a renowned Harvard astrophysicist has drawn extraordinary worldwide attention, capturing both the public imagination and the scientific community's curiosity. The warning, which advises people to take a vacation before October 29th, has sparked waves of speculation, debate, and even anxiety. At the center of this global intrigue is a mysterious interstellar object known as 3I/Atlas, an enigmatic body whose trajectory, composition, and physical behavior appear to defy the known laws of astrophysics. Classified as the third interstellar visitor ever detected entering our solar system, following Oumuamua in 2017 and Comet Borisov in 2019, 3I/Atlas distinguishes itself through characteristics so unusual that some experts have considered the possibility of an artificial origin. While mainstream scientific institutions remain cautious, the object's features have fueled intense speculation, particularly because they differ sharply from every natural celestial body previously observed. Measuring approximately 5.6 kilometers in diameter and possessing a mass estimated to exceed 33 billion tons, 3I/Atlas is comparable to the size and weight of a small city. This alone is remarkable, but what has further perplexed researchers is its extreme velocity, almost twice the speed expected for interstellar objects of its type. As it travels through the inner regions of a solar system, it moves at a pace that challenges established astrophysical models governing gravitational behavior, acceleration, and cosmic drift. NASA, European observatories, and independent telescopes worldwide, including highly sensitive instruments in Chile, Spain, and Hawaii, have all confirmed its presence, its trajectory, and several aspects of its composition. NASA has repeatedly assured the public that 3I/Atlas poses absolutely no threat to Earth. According to its calculations, the object's orbit keeps it at a comfortably safe distance, with no realistic possibility of collision. Nonetheless, the object's behavior remains so puzzling that even seasoned astronomers admit they cannot fully explain its properties using conventional theories. One of the most puzzling characteristics of 3I/Atlas is its remarkably precise orbital alignment. Unlike most interstellar objects, which tend to enter the solar system at steep, random angles due to their origin from distant and unconnected regions of space, 3I/Atlas travels at an angle of only about 5 degrees relative to the plane of planetary orbits, known as the ecliptic plane. This subtle but important detail immediately caught the attention of experts. An object entering from outside the solar system should statistically be oriented in virtually any direction. Yet 3I/Atlas appears to be navigating along a pathway nearly parallel to the planet's orbital alignment, a phenomenon considered extremely rare. Such alignment has led some researchers to privately speculate whether the object could be following a guided trajectory, although this remains a highly controversial idea and one that mainstream institutions are hesitant to endorse without overwhelming evidence. Adding another layer of complexity to the mystery is the behavior of the gas jets emitted by 3I/Atlas. In naturally occurring comets, gas jets or outgassing streams are typically directed away from the sun as solar radiation heats the surface and sublimates icy materials, pushing vapor outward. Surprisingly, in the case of 3I/Atlas, the jets appear to point toward the sun rather than away from it, contradicting the fundamental physics governing how comets and icy celestial bodies behave. This anomalous outgassing has deepened suspicions among some researchers, who argue that such behavior could imply a form of controlled propulsion or an engineered mechanism rather than random natural processes. No known natural object displays this pattern, making it one of the most compelling pieces of evidence cited by those contemplating an artificial origin. Observations conducted with the Keck 2 telescope in Hawaii produced findings that further intensified scientific debate. The telescope detected significant emissions of nickel tetracarbonyl, a chemical compound not known to occur naturally in space. On Earth, nickel tetracarbonyl is a highly toxic substance produced almost exclusively through industrial processes involving metallurgy and chemical engineering. The discovery of this compound in the emissions of 3I/Atlas stunned researchers. Even more baffling, The object releases approximately 4 grams of pure nickel every second, yet contains no detectable traces of iron. This combination is unprecedented in all known celestial bodies, as iron is one of the most common elements found in asteroids, comets, and planetary debris. The absence of iron and the industrial-like signature of nickel tetracarbonyl led Harvard astrophysicist Avi Loeb, a figure known for his open-minded approach toward unconventional scientific questions, to publicly state that the chemical profile represents one of the strongest indicators, yet that 3I/Atlas may not be a natural object. Loeb emphasized that, despite numerous attempts, the scientific community has not produced a natural explanation capable of accounting for all the object's unusual features simultaneously. He argues that when an astronomical object displays multiple deviations from natural patterns, its alignment, its composition, its jets, its velocity, and its chemical emissions, scientists have a responsibility to consider alternative possibilities, including the hypothesis of intelligent design. While Loeb's statements have garnered significant media attention and sparked global curiosity, they have also ignited controversy. Many astronomers caution against jumping to conclusions and warn that extraordinary claims require extraordinary evidence. They insist that while the anomalies are intriguing, they may one day be explained by natural mechanisms not yet fully understood. Researchers at the University of A Coruña in Spain recently published simulations suggesting that 3I/Atlas may have formed as long as 10 billion years ago in a region of the Milky Way known as the thin disk. According to their models, the object could have been shaped by gravitational interactions over billions of years without requiring any artificial interference. Spanish astrophysicist Pérez Couto argued that each anomalous observation should be seen as an opportunity to learn more about the universe's past, especially regarding how matter behaves and evolves around distant stars. His team conducted 93 different simulations of stellar encounters to determine whether any scenario implied manipulation or artificial structuring, but none of the models exhibited characteristics suggesting an engineered object. From this perspective, 3I/Atlas becomes a window into ancient cosmic processes rather than an extraterrestrial artifact. Nevertheless, Loeb's statements have had profound ripple effects. Public curiosity has intensified, and social media conversations have exploded with theories ranging from alien probes to interstellar spacecraft to unknown cosmic technologies. The controversy grew strong enough that NASA was compelled to issue repeated clarifications, reassuring the public that 3I/Atlas poses no threat to humanity and that there is no imminent danger associated with its passage through the inner solar system. The agency emphasized that while the object is scientifically fascinating, it is merely a visitor passing through space, and all available data confirm that it will continue on its path without interfering with planetary bodies. Yet, despite NASA's confidence, many independent researchers and members of the public have begun calling for complete transparency regarding the images and data collected by space-based observatories. Some have specifically requested the release of raw, unprocessed visuals gathered by instruments, such as the Mars Orbiter and the Solar Terrestrial Relations Observatory. These researchers argue that open access to unfiltered data is necessary to ensure scientific integrity and prevent institutional bias. Loeb himself has echoed this sentiment, stating in recent interviews that the global public deserves full transparency when dealing with phenomena of potentially historic significance. He insists that science must remain open, collaborative, and unrestricted by bureaucratic filters. According to him, society should see the raw data instead of relying solely on carefully curated official statements. As a result of the intensifying conversation, 3I/Atlas has evolved from a simple scientific curiosity into a symbol of broader questions about humanity's place in the cosmos. Whether or not the object is artificial, its appearance challenges our understanding of cosmic chemistry, celestial mechanics, and interstellar dynamics. It forces scientists to consider possibilities once dismissed as speculative fiction. At the same time, it reminds the public of how much remains unknown and unexplored in the vastness of space. With each new observation, the debate deepens, bridging scientific inquiry with philosophical wonder. The mystery of 3I/Atlas continues to unfold, leaving the world to watch, question, and hope that its secrets may one day reveal a deeper truth about the universe, and perhaps even about ourselves.